Okay, we're live. Hi, hello, hey, hi there. Hello, hey, folks. So this is the PS Power. We're going to do a bunch of PowerShell community lightning talks. I don't want to take up too much time. Presumably, you're here because you want to listen to the content. So I'm just going to go ahead and introduce our first speaker today, which is Glenn Sardi. Glenn, take it away.
Hi, everyone. Can you hear me fine? Hi, I'm Glenn Sardi, and back in
Glenn, looks like you muted yourself. You may want to back up a little bit and then start over.
Oh, there we go. How about that? Is that better?
Much.
There, I can actually talk now. All right. So again, hi, I'm Glenn Sardi. Back in 2010, the term DevOps was first coined by Damon Edwards and John Willis. And DevOps had the 4 pillars of CAMS, which was culture, automation, measurement, and sharing. And sharing was so important that it had its own pillar. And yet, I went back through all the previous DevOps Days conference talks, and in more than 1,500, only a handful were about sharing. So today, I want to help even that score by appealing to your selfish side and answer the question, sharing, what's in it for me? And strangely enough, the most selfish way to share is not to share with anyone at all, but instead share with a rubber duck. So rubber ducking is a technique that as you share a problem or idea with a duck, it helps the solution become clearer. You start talking about a complex problem and then mid-sentence, bing, this light bulb goes off and the answer just appears. Now, there are many thoughts about why this works, but here's 2. The first is that your mouth is slower than your brain. When you're speaking to your duck, it forces your brain to slow down and process the information in depth. And the second, you need to take into account what the duck knows, which is nothing. It forces you to think from another point of view and then see other solutions. By taking the time to explain your problem to a duck and provide the context that the duck needs to understand, you're telling a story. And storytelling is a very powerful tool, because we are wired to listen and to tell stories. And there's one story that is the most important to us all. It's our own story, and this is autobiographical storytelling. So this is Dr. Sherry Hamby, who is a research professor of psychology at the University of the South. And she's also the director of the LifePath Research Center, which is an institute devoted to learning about the ways that people develop personal strengths and cope with adversity. And one of the areas she investigates is storytelling as a means to deal with adversity. She says, I've been surprised at the power of emotional autobiographical storytelling. This means writing about events and people that have mattered to your own life, not just describing the facts of your life. Research shows that even brief exercises can have substantial impacts on psychological and physical health, even months after. So in particular, Dr. Hamby says that through this kind of storytelling, we can build our resilience to adversity. She and her research team found 4 benefits. Firstly, finding your voice. This means learning how to express yourself and how to think about what has happened in your life in a way that makes sense. So it may appear that events in your life are random, but it doesn't help to think about them like that. Instead, when we write, we have a beginning, a middle, and an end. We can start to see how experiences, good and bad, have shaped us. And finding your voice is just like talking to that rubber duck. You're taking a step back and talking about the context that makes each detail important. So secondly, reaffirming your values. Just by writing a story, it can show where your focus is and clarify what's important to you. Also, what you choose to leave out or minimize can show what is trivial to you. And that light bulb feeling when you talk to the duck, you get that same feeling when you start reaffirming your own values. Thirdly, sharing your story. Writing your story is good, but sharing is an underappreciated aspect of storytelling. When you share your story and pass on wisdom, you realize your words can be a positive power on other people. And if you feel nervous about sharing your story to other people, first share it with your duck. There's the same benefits as if it was a highly technical problem. It will help you clarify your voice and values, so when you do actually share your story, it will be amazing. And lastly, building resilience. Once you have found your voice, reaffirmed your values, and shared your story, it builds a sense of well-being, which then builds resilience for when adversity next strikes. So resilience is strengthened by recognizing that we're all experts in our own lives and we all have something to share with others. So how do you start writing stories then? Well, it's quite possible you're already doing this. If you have a blog, I'm sure you're writing stories that you want to tell that matter to you about problems you overcame. Or perhaps at your job, you've written a post-mortem for an outage. While they tend to be less emotional, they are stories and they are definitely rooted in adversity. Or if you write technical documentation, in particular narrative-based documentation, or code comments or articles in your company wiki, or even answering questions on forums like Stack Overflow. These are all forms of autobiographical storytelling, and through this, you can find your voice and values and share your story. And this is also backed up by investigations into the IT industry. So the Accelerate State of DevOps reports team, led by Dr. Nicole Forsgren, specifically looked at the culture of teams and cautions organizations not to ignore the importance of their people and culture in digital transformations. The research found that when leaders give their teams autonomy in their work, it leads to feelings of trust and voice, which then positively influences organizational culture. And this is the same voice that is found during autobiographical storytelling. A good leader will encourage its team to share its stories, which again builds resilience for when conflicts arise. Research showed other benefits. Elite performers are 1.5 times more likely to hold retrospectives than low performers. Having a climate of learning within your organization is a predictive of performance gains and is a strategic advantage for teams. None of which is possible without people sharing their stories and knowledge. Sharing is a crucial component of any high-performing team, and without it, we're stuck in low-performing teams, which no one wants. But let's think a bit bigger than our own team or even than our own organization. Let's think about sharing your story and your experiences to the wider IT industry through mentoring. So Chris Howard gave an inspiring keynote at the DDD Perth conference in 2017 called the Campsite Rule. And the rule originated from Robert Baden-Powell: to leave this world in a little better than you found it. And you get a lot of benefits from being a mentor. It's not just giving advice, it's a conversation, a partnership. You get as much out of it as you put into it. We can battle imposter syndrome by becoming confident in our own abilities. We can gain a broader perspective by talking with other people. Mentoring improves your communication skills by default because you have to get good at explaining your ideas in different ways. Leadership isn't so much about what you do or say, but how you influence other people with communication. And just because you're not a manager doesn't mean you're not a leader. And as your perspective shifts, you'll adventure into new ideas. And this allows you to question or consolidate your own technical beliefs and truths. And then this then leads you to try out new things or technologies which you may not normally consider. And as human beings, it feels good to connect and help other people. It's a massive buzz to see someone do what they didn't think they could do previously. And there are many different types of mentors you can be. Again, it's not just this wise sage. There are inspirational mentors, career mentors, tech mentors, champions, and peers. And you can be different types to different people at the same time. And no matter what type of mentor you are, you will create tangible opportunities to make IT better. Now, as much as I'm painting this whole sharing things as rainbows and unicorns, there is a darker side here which we have to talk about. We all have the ability to share, but it's not safe for all of us to do so. Daily, we see occurrences when someone shares something, like a code snippet, an opinion, or heaven forbid, an alternate way of doing something, and they are harassed, bullied, and threatened. But responses to sharing don't just have to come in these overt forms. It can be more insidious and passive. The junior developer who suggests something but is dismissed by a senior developer, or the new member on a team who asks a question but is ignored, or someone else taking credit for an idea that you shared. People are sharing their stories, their thoughts and ideas, and never get to reap their benefits because it's not safe to do so. And you can see the effects in our workplaces here in Australia. This is an extract from the State of Workplace report back from 2014. 91% of employees believe that mental health is important, and yet only 52% believe their workplace is mentally healthy. Half. That's a shockingly low number. And mental health and psychological safety isn't just important for your own well-being, it's a predictor of high-performing teams. Not your technical achievements or org structure or mission statement, but team dynamics and safety. And so if you have a voice in your community, if you enjoy the privilege of being able to share your stories without retribution, then you have an obligation to afford others the same. It's the price of admission for sharing. give others the space, and most importantly, the safety to share their stories too. So to answer sharing what's in it for me, solving my own and my team's problems, thinking from other people's perspectives, increasing my resilience and mental health through stories, improving my own professional skills through mentoring, and lastly, making IT industry a better place to be. So I'd like to finish with a final thought from the poet James Russell Lowe. For not what we give, but what we share, for the gift without the giver is bare. Who gives himself with their arms feeds three, themself, their hungering neighbor, and IT. Sharing, be it your story, your code, or your knowledge, feeds the sharer just as much as those you are sharing to. And remember to always make room for other people to share safely too. To leave IT in a better way that you found it. Thank you.
Thanks so much, Glenn. Okay, next up we've got Francisco Navarro. Francisco, take it away.
All right, thank you. So today I'm going to talk about Automated Lab and running it inside of Hyper-V Host 2016. So I was looking for a way to better manage my time, especially when I have a lot of things going on in general. We all do. I don't like building labs the way I learned to build servers back in 2005. I need some automation to save some time. So I'm also limited on resources in my home lab. So instead of running a full-blown desktop OS, I run Hyper-V Host 2016 on my machines. So how do I create labs really quick? Enter Automated Lab. So this is just a huge amount of PowerShell modules, and essentially they help again with the process of building VMs versus using the full-blown PowerShell. You kind of minimize your code footprint using these modules. So how do we get started? You can install Automated Lab with an MSI installer. Thing is, I'm running Hyper-V host, and I'd like to go ahead and install the module on Hyper-V. The Hyper-V host does have PowerShell get, and we can go to the PowerShell gallery and pull down the module. So we're going to run install module, the name of the module, Automated Lab, allow clobber, and that should get your module going. Now, in my case, I already have the module installed, so let's go into my Hyper-V host here. And just so that myself on is here. Okay. Okay. All right. So here I have a bunch of scripts that were provided by Automated Lab to kind of quickly build a VM. So we're going to go through just building a simple VM since we have limited time. As you can see, I'm going to go ahead and show you that I already have the module installed. Oh. Okay. That's right. I'm going to have to import it first. All right, now let's go ahead and see if we have the module loaded. And there you go. All right. So initially, when you run the module, I've already run it here. So I'm just going to show you some screenshots. You run into these couple questions of enabling WinRM and CredSSP, if you want to enable it on your actual host. I would go with the defaults of yes all the way. You're going to get asked a couple more questions. And again, I would just go ahead and hit yes, especially if you're not running a domain. And here it's the same thing. It wants to enable a registry key change for that CredSSP vulnerability. So again, I would just go ahead and hit yes to that until you get to the point where, you know, the module is ready to go. So let's go back to our first. And it's as easy as that. We just run a script, right? And then you're going to get the verbose information about what is going on. It's going to try to find an ISO, and that's another thing that you need as a prerequisite. If you go to the automated lab README file in GitHub, you're going to need some ISOs. And as you can see here, I've have a lot of ISOs that are from the Microsoft evaluation. So let's go ahead and show you that really quick. I have access to the drive. Here you'll see that I have a bunch of ISOs either for Windows 10, Windows Server, even a Hyper-V ISO. And again, this is where the automated lab is going to pull an ISO. What's going to happen is it's going to use the ISO and create a VHD that it can build off VMs later on. And I've already done a initial VM just because it takes about 17 minutes to create your initial VM. And that includes the build time of the VHD. So I already have a VHD built out. What I'm showing you now is the actual script of how you would build the VM. So I'm going to give the lab itself. It's kind of you can think of it as a resource group in Azure, right? It's a container for the VM and the resources you're going to give it. That way, if you wanted to isolate your labs, you can. So I'm going to call my lab PowerHour. I'm going to go ahead and give the lab a lab definition. Essentially, I'm going to tell it where I want to put my actual VM and what type of hypervisor I'm going to use. Since you can use this module, you can use it to deploy to Hyper-V desktop. You can use it to deploy to Azure. You can use it to deploy even to VMware ESXi hosts. In my case, I'm using the module inside of a Hyper-V 2016 host. So I'm going to tell it Hyper-V as my virtualization engine. Then I'm just going to go ahead and create the network. So it's going to create a network space. I'm also providing it the credentials I want the VM to use so that it automatically logs in and that I don't have to actually create the account. The automated lab module will create a user account, the initial admin account for me once I provide the installation credentials. Then I went ahead and splatted out the lab VM specs. These are not in the initial scripts that were provided as samples. It could be very daunting. They actually kind of look like this, where nothing is kind of really splatted. Well, you have a section here that is splatted, but they can get complex. In this case here, I don't have enough time to build out a whole domain, but that script here will go ahead and do that for you. Okay, and again, last but not least, I'm going to go ahead and install the lab. Then we'll get the verbose information of how the lab is doing. And at the end, I want to show the actual summary, right? I want to see whether the VM built out failed or it was successful. It even provides the IP address that was provided by the networking something that was created up here.
2-minute warning.
Okay, good. So let's go ahead and make this roll here. So as you can see here, we're already seeing the initialization of the VM being built. It scanned for ISO images. I actually, in the script, provided an ISO name that it should use in my VM specs. Let's go back to that while this is being created. So I went with a Windows Server 2016 data center evaluation. And I'm going to pull up the Hyper-V Manager here. And you'll see that the VM is being built. You could also see the verbose login MVS code. And essentially, it even provides an instruction here as to how to clean up the VM, similar to kind of like using Vagrant when you Vagrant up and, Vagrant destroy. So let's see what happens when I go ahead and connect to it. There we go.
Unfortunately, thanks for that is time.
Sounds good. Well, at least you got the bulk of it. Thank you.
Hey, no problem. We could follow up with you later online if people want to reach out on Slack. Okay. Next
Sounds
up is Brandon Olin here to talk to us about chat ops.
All right. So, hello everyone. My name is Brandon Olin, Dev Black Ops on Twitter, and like Michael said, this is a quick little demo of how you can do chat ops with Microsoft Teams and with Poshbot. So let's get started. To give you a quick overview of what Poshbot is, it is a PowerShell module that connects to external chat clients like Slack and Microsoft Teams and even Google Chat, and allows you to execute commands within the chat network and have those commands be run on a system. And specifically with Poshbot, it executes PowerShell commands inside modules. And what this allows you to do is kind of distribute out your automation to more people. You can kind of think of using tools like Slack and Teams and executing commands as kind of another user interface to like a self-service portal, and all the benefits you can get with distributing these commands and allowing other people to execute them versus holding them tightly to yourself. So there's a number of features which Poshbot can do, and which I kind of list here. It has a notion of role-based access control. It, like I said, it executes the public functions that are shipped inside PowerShell modules. It exposes those inside the chat system. You can do scheduled commands. You can have a notion of command approvals where two people have to agree to execute the command, kind of like the two people have to turn the keys to launch the missile type scenario. There's a notion of parameter injection where you can ship a module to someone without shipping the secrets, and then you can have the bot framework inject those secrets at runtime. There's a notion of stateful data where you can save the state of a command for later, and then when it executes again, you can kind of rehydrate that state and then continue on. And a lot of other features, including custom middleware, where you can kind of hook into the running of how Poshbot executes a command and how it does authentication, and tweak that to, as you see fit with custom PowerShell scripts. So the rest of this, I want to talk to you about how Poshbot works with Microsoft Teams. Before I do that, this is a quick diagram of how Poshbot originally works with Slack, and you can see it's a fairly simple process in that Poshbot is connecting into Slack, and it does that via a WebSocket connection, and it receives those messages as people enter them into Slack, interprets them, parses them, figures out if what the user entered was supposed to be run by the bot. It goes and executes that command, retrieves the results, and send those back into Slack. Now with Teams, it's a little bit different in that the way Teams uses chatbots is a little bit different, so it's a little bit more involved. But the gist of this is that Microsoft Teams will send a HTTP post with a JSON payload to Microsoft Bot Framework. In Microsoft Bot Framework, you register in this case with Poshbot, you register a Azure function that message will get sent to. That Azure function, its sole job is to drop that onto a service bus queue. You can see here in step 4. And then what Poshbot is doing is it's actually listening to that service bus queue inside your firewall, inside your corporate network. It's making an outbound connection to that service bus and listening for those messages, similar to how it does with a WebSocket connection in Slack. And then it will take that JSON payload, interpret it, run the command, and send the results back to Teams. So let's actually see what this looks like in real life. You can see here I have this start Poshbot script. What we're going to do here is import Poshbot. We're going to load in a configuration file. And this configuration file just includes some basic settings for how you want the bot to operate. What is your list of admin accounts for the bot? What character do you want to kind of denote messages for being bot commands, and lots of other settings. Here you can see I am loading up some custom secrets into the configuration, and these will get exposed to chat commands as needed. And then here I'm also defining who will be the admin of the bot, and also creating a backend instance. And this is all the information that is necessary to wire up Poshbot to Teams. So you can see here I've denoted my Microsoft Teams ID, my service bus namespace, the queue, and the SAS key for the service bus that I'm going to connect to and start receiving messages. And then we will go ahead and create a new bot instance and then start it up. So let's do that. And in just a second here, it'll be fully started. Okay, there it is. And what Poshbot is doing now is it has a persistent connection into service bus, and it's listening for messages. So let's go into Teams and start a message. So with Microsoft Teams, in order to talk to chatbots, you have to @mention them. So I've already configured a bot in Teams called Poshbot, and I'm going to send a message. And what that is doing is that will get sent to an Azure function. The Azure function will drop it into a service bus queue. Poshbot will consume that message, interpret it, run a PowerShell command, get those results, and send those back into Slack. And you can see here I'm just running a simple status command. Let's go ahead and actually import a normal PowerShell module from the PowerShell gallery, just to kind of show that you can execute many different types of modules, and even modules that are not specifically designed for Slack or for Poshbot. I'm going to install the name it PowerShell module, and what this module does is just basically generates random string data for different use cases. And it's a good example to use because it deals with just simple strings. From the base verb noun command inside that module. And you can see it executed the command. What Poshbot actually did was execute that command inside of a separate PowerShell job and read the results back and then send them back into Teams. So here's another quick example of one fitting that Glenn mentioned rubber duck debugging. I recently, it's kind of a silly thing, I actually created a Poshbot plugin to do that. Oops. I believe I called it poshbot.duck-debug. Let's see if that's actually installing. Yeah, it is. It's taking its time though.
Right about 2 minutes.
Sure. There you go, installed. Oops, gotta always mention the bot. And there you go. Now there's a lot of other commands that you can do in PoshBot, but let me just show you kind of a this will be in the GitHub link. Is that this sample PowerShell module includes a lot of sample PoshBot commands that you could run to kind of highlight the different capabilities of PoshBot. You can also do list of running plugins inside the bot.
About 30 seconds.
Sure. And let me get back to the slides. Here is kind of a simple list of most of these PoshBot modules I've created. Some of them other members in the community have created. This kind of gives you a good sampling of the different types of things you can do with PoshBot. And that's all I got. Again, my name is Brandon Olin, Dev Black Ops on Twitter, and you can find PoshBot at github.com/poshbot.io.
Thanks so much, Brandon. Next up, we have Nate. Nate, take it away.
Thanks, Mike. All right, my name is Nate Farrell. I am an AWS certified systems engineer, solutions architect, developer, and sysadmin associate. Today, I'm going to give a quick intro to PowerShell Core on AWS Lambda. PowerShell Core was recently added or recently supported within AWS Lambda, I believe a couple months ago now. And it's pretty great so far. Coming from a Python-based Lambda background, it's much easier to work with, in my opinion. But let's get into it. Some of the prerequisites that you are needed for developing PowerShell Core-based Lambdas are obviously PowerShell Core. You will need the AWS Lambda PS Core module for PowerShell Core, the .NET Core 2.1 SDK, and then optionally, and I find it very helpful to have, is the AWS PowerShell .NET Core module as well. Some key points that come along with this: Windows PowerShell is not supported. It's only PowerShell Core. If you want to log anything, it's really simple. Logging to CloudWatch, you can just use any write commandlet like write host or write verbose. If it would output in your normal session, it will output and show you the stream it's outputting to within CloudWatch. One of the biggest things that I found easier in PowerShell compared to Python with Lambda is you already have your event and your context in a predefined variable. The event itself is in this Lambda input variable. The context is in this Lambda context. The general rule of thumb with PowerShell Lambdas is the last item returned in your pipeline is basically the object returned to the client. For an API, which is what I'm going to demo here, you're basically returning a hash table, and that would be returned to the caller. Any PowerShell modules that you want to include, you basically just add in a require statement at the head of your script. And if you ever forget any of this, a lot of the templates that come with the AWS Lambda PS Core module actually come with a commented out help section that lists all these points more or less. So to get into it, what I'm going to build real quick is a REST API that is PowerShell backed, just kind of like a hello world example, just to show you how quick and easy it is to get going. So I have PowerShell core running right now. So I'm going to create a basic template using the new AWS PowerShell Lambda command. So we'll create it in my current directory. All this is doing is creating this readme.txt and a sample hello world script. Super simple, nothing crazy. I'm going to add my actual API logic to this. Couple things to note about this section. I want to see what's coming in on that API input. So I want to log that Lambda input. And I want to just verbosely see what that context is, just to kind of demo the different information streams. I'm going to build a result string. The URL that I'm going to expect is going to have the last URL segment with a name, and it will format that into a string and return this back to the caller. So let me just add that to my script real quick. And here's what I mean about having those predefined tips. Super handy, great. We don't need any of that. So we're just going to blow that away and save. Yay. While that restarts, the next thing that we are going to do is create our package zip. New AWS PowerShell Lambda package will take that script and create a zip file with everything packaged up the way we need to, so it will actually run on Lambda. Boom, zip is created right over here. Next, we're going to use AWS CloudFormation package to take that and upload it to S3. The only thing that I really prepared outside of running through this exercise was the CloudFormation template that's going to deploy this. This is pretty basic. Some of the key points that you're going to want to note is the name of your script is going to be your handler. So just keep that in mind. There's a bunch of great documentation on AWS's doc site that kind of go over that in a little bit more detail, but this is the only thing that I had prepared. Wanted to run through it really quick. So we'll go ahead and package that up. This is going to upload it to S3 and output this additional YAML file, which contains our resolved template. There's our updated template. Just basically gave us that S3 path instead of the local file path. And let's deploy it. So go ahead and deploy it and wait for it to actually go through. Should be relatively quick, takes about a minute because it's a relatively small stack. Lambdas are pretty quick to spin up. Almost done, and we are done. The prompt should return momentarily. As soon as it sees that it's done. All right. And last but not least, we are going to grab that URL from our stacks output values. This is basically what we're outputting. This is going to be the URL to our API. And we're going to concatenate our name. We'll use PS PowerHour here and then make a GET request to it. So there we go. Quick, easy REST API with PowerShell in AWS Lambda. It usually isn't any more difficult than that. That went into a little bit more length than some people even need to go to, since I did use CloudFormation and spin up a couple additional resources. But if you just want to deploy a Lambda and you don't want to deal with packaging it, you can do that as well directly from PowerShell, and it'll be ready almost instantaneously. There's some additional links I have here, and this will be available within the resources once I submit my pull request. And that's basically it for me.
Thanks so much, Nate. Next up, Andrew.
Hey there, thanks, Michael. All right, hopefully you can see my screen. So my name is Andrew Wickham. I'm a SQL Server DBA for 10 years now, father of 2 boys and a lovely wife. I'm a runner sometimes, so I've done about 12 marathons, but been on a little bit of a hiatus. And blogger, not really. A couple posts out there, but that's about it. So I'm going to talk to you a bit about Graylog and PS Framework and how you can improve the troubleshooting process for your scripts with a minimal amount of effort. So why logging matters? Scripts are great, except when they're not. We need to know things like what happened or didn't happen, when it happened, and why it happened. Without logging, good luck. So what is Graylog? Graylog is an open source management platform. It allows you to store, analyze, and alert on your logs. It's centralized, so you can share these logs with your developers, with your admins, whoever you want. So it's a little bit like Oprah's favorite things, that everyone gets logs. And what is PS Framework? So PS Framework is a module written by Fred. I'm not going to try to pronounce his last name. It's a module that provides tools for other modules and scripts. I'm not a developer. I don't want to worry about this stuff. Writing a function to do logging is not something that I find enjoyable. There's also a bunch of configuration settings and commands in there, but I'm not going to be covering that. And finally, we have PS Guelph. So PS Guelph is a module by Jeremy McGee, and it will actually do the sending of logs to the Guelph server, which is Graylog. So the command we'll use there is send PS Guelph TCP. So now it is time for some demos. All right, so we're just going to cover real quick the different modules and a little bit about each of the commands. So PS Framework is out in the gallery, so you can install it just like any other module. Install module PS Framework. And our first command, write PSF message. Okay, so we've got message on the screen. That's helpful. Did that go anywhere else? Is it logged anywhere? So you can see here with a git PSF config, there's a ton of options right here. The only one we care about right now is this PS Framework logging file system log path. So we look there. That's the default log path where PS Framework outputs any of your messages. So we're going to go ahead and we're going to open that up. All right, so you can see there we've got a CSV file now that has my hello world message that I just wrote out. So it's formatted pretty nice. You can analyze this with Excel, import CSV, however you want to do it. So now how about verbose messages? Let's see here. So nothing outputted to the screen, which is what we'd expect. We don't have verbose set. But we can go back to our log and we can actually see that it went into the log. So that's pretty helpful. I don't know about you guys, but I don't run verbose all the time. So if I run a command and it doesn't work, I'm going to have to run the command again with verbose on, where if you're using this, it's already out there in the log file for you. So let's turn verbose on and we'll output again. And you can see it outputs to the screen now, which is exactly what we would expect. And it's in our log. So we're now going to turn off our verbose. Now a little bit about the PSGelf module. It's the same deal here. PSGelf is published out on the gallery, install module, and you should be able to get it. Let's clear host. And then this is a pretty simple command, send PSGelf TCP. This is our Gelf server address. I'm actually running Graylog in a container on my laptop for this demo. So we've got localhost, port number, and a little message there. Okay. We go over to Graylog here. There we go. You can see our message. All right, so our next demo. Now we're going to start to get a little bit more into a real world scenario. Okay, so what are we doing in this script? We're going to add a local user, and we're going to add that local user to the local admins group. So maybe this is something that you would see in an end user client build or a server build process. So we're going to get some credentials, whatever I tell to create. Then we're going to create the local user. Our developer of this script was nice enough to put a little write verbose in there. And then if it fails, we've got a write error. Unfortunately, there's not much info with that error. So same thing with adding to the local group. Go ahead and run this. And then we're going to do an awesome admin. Okay, ran good that time. But what would happen if this happened again? Awesome admin gets added again. And now it looks terrible. So now all my coworkers are probably going to walk by my computer and they're going to make fun of me because there's red all over my screen. So what could I do to get some better logging of this information? If this was automated, I could spend quite a while trying to troubleshoot why this script errored out. I would have no idea that the awesome admin user was already in the group, and it could take quite a while. So in comes PS Framework. So all I did in the script is I went through and I changed all of my write verbose, write error, and write host commands to write PSF message with an appropriate level parameter. For errors, I did throw on a reference to the exception and the error record property. So you can see here, write PSF message level verbose. And then in my catch, I've got to write PSF message level critical, along with a reference to my exception and the error record. So I did this throughout the whole script. So we run this time, looks a little bit better. I don't think coworkers are going to yell at me quite as much. And if we go over to our logs, we can actually see all of our information in there. So with a minimal amount of effort, I minimize my troubleshooting process, right? If this script failed out, I could go out to this log, I could see this information and pretty easily be able to tell, oh, well, the admin user already existed, so that's why it erred. Now the question is, what if this was an automated server build process? How could we alert on that? Again, going back to, I'm not a developer, I don't really want to try to figure out how to write an alerting function and make it durable so it doesn't just cause problems in my scripts. So here's where Graylog comes in. We can actually create alerts in Graylog.
About 30 seconds.
Okay, I'm wrapping up right here. So last demo here. Let's check out what the login providers are. You can see we have a Guelph login provider. I'm going to configure that login provider, point to my Guelph server, my local host. I'm going to verify that I enabled it. We can see it's enabled now. And then I'm going to just run that demo again. Some admin. So now I can go over to my Graylog. Refresh here.
We are at time. We'll let it load out.
There we go. So now you can see that my messages are in Graylog with no changes to code at all. Thanks for the time, Mike. I really appreciate it. I hope you guys enjoy the rest of the demos.
Sure. If you guys would like, follow up with Andrew on Slack afterwards. Next up, Kirk. Take it away.
Thanks. So, hi everybody, my name is Kirk Monroe. I go by Pashaholic on Twitter, or you can find me on GitHub, just looking for github.com/Kirk Monroe. I just wanted to do a bit of show and tell because I've been spending some time doing a bunch of PRs, kind of started looking at them in October for Oktoberfest, and now switched over to continued past that and actually fleshing out some more extensive PRs, and particularly in the debugger. And so, if you guys have any feedback on these PRs, by the way, I'd like to hear it, and you can find them just by going to the PowerShell repo and looking for PRs that are opened by author Kirk Monroe, and then you'll find the PRs that I'm going to be showing you here. So let me just jump over to demo. Now, all right. So what I've got here is just 3 different scripts that are related to 3 different PRs that I've recently been working on. None of these are fully accepted yet, but they are going through the process of review and acceptance right now. I don't see any issues with these ones being accepted other than minor changes, and so I thought it was a good time to show them. So the first one, let me just do Notepad here. Whoops. Notepad #1. And so you guys already know there's different streams out there. There's write verbose, there's write debug. Write debug has been around since version 1, so is write verbose. And write debug was originally used for a way to allow somebody to enter a debugger, and I'm doing air quotes here that you can't see. Version 1 of PowerShell did not have a debugger. And so if you used write debug and you ran a command with -debug, then you would get asked, do you want to enter a nested prompt? And that would allow you to look around and see what's going on. It's not a debugger, it's a nested prompt. It's not quite the same thing. And so just to show you what that looks like in PowerShell core, if I just sort this file, and so I run my script, it shows my verbose output right off the bat. And then when it gets the debug output, it shows it, and then I get this question. And that's ever since version 1 has been finished and version 2 commit with the debugger, this has kind of annoyed me because I would prefer to have multiple streams, a separate verbose stream and a separate debug stream. So from here, this is just using the functionality that's been around since PowerShell v1. I can suspend the operation, throws me into a nested prompt, and from here, I can look around. I don't have a debug context because I'm not in the debugger. I don't have the help command to see the debugger command. That's actually running history, because all this did was pull me into PowerShell in a nested prompt, which was the version 1 way of allowing you to do some kind of debugging, but you're not in the same scope, and so things don't work quite the same way. So, and to get out, you just have to exit, and then you can continue and run the rest of the script and finish the work. So what happens when you run a command with -debug, if I go back to the script file here, that sets debug preference to inquire. The inquire action preference is that nag prompt that says, hey, do you want to continue with this operation? And that's been the default forever. And so what I've done is now, let me make sure I'm in the right version here. Yeah, exit to there. What I've done in my PR is I've changed -debug so that it actually sets it to the debug preference to continue instead. So now if I .source the same script file here, now I just get debug output. I don't get prompted. And that is a much better experience for me, because if I wanted to enter the debugger, I would put breakpoints. I wouldn't use -debug. The other reason why this is really important, because there's only been verbose output always showing as output and not both verbose and debug without the nag, developers have been just using verbose and only verbose for everything. And so if you do import module, AWS PowerShell, core -verbose, then if you look at the volume of information that is shown here, this is much more than what I want to see for verbose. Forget that error there. That's a bug from the most recent version I installed. But just looking at the volume of those messages, these messages are not useful verbose messages to me. These might be useful debug messages, but as far as verbose, I want to see some extra details that might help me as an end user troubleshoot a problem, versus debug, which is more built for the person who wrote the module, for them to see what's really going wrong when something didn't work. And so that's kind of where I draw the line in the sand between two different streams and why I want two different streams. And so this PR is about bringing this into the future, or I should say into the present, and allowing you to use -debug and just get debug output. And the PowerShell team likes it, so it looks like it's going to go through. I'm just waiting for final approvals on that one. Now, was that the only thing with this one? Yeah, so just -debug making it work, so it just turns on the debug stream. Let me go back to the second file that I had. So second PR, break action preference. Now, this didn't exist in any versions of PowerShell before, and it's not in PowerShell core yet, but I'm hoping it'll be in the next update once they accept the PR. And so this, if you follow Adam Bertram on Twitter, he recently put out a tweet saying how you could try to get the debugger to enter and allow you to a dynamic breakpoint, allowing you to debug when you hit an exception. This puts in native support for something similar to that, which is on error actions. So if I .source this file in my custom build, .source action preference. And so when I run this, flipping back over to the file, this just loads up my function, runs test break on error with error action break. That's net new, a new error action preference. And the moment that I hit a non-terminating error, meaning not an exception that's thrown, just an error that's not terminating, the debugger stops immediately before the error even shows up. And I'm on that line, letting me know, okay, I hit an error. That might be unexpected. If I look at PS debug context, I can see there is no breakpoint, but I hit this, I entered the debugger because something triggered it. Well, what was the trigger? I added that trigger property on the debug context so I can take a look at, actually I don't need that. So I can actually look at what the trigger was, which in this case wasn't the actual error message, and I can pipe that to format list star dash force and see all the details showing me it couldn't find any service with that service name. So I can do my troubleshooting, and whatever error caused the issue is going to be set in my trigger, and then I can start trying to see what's going wrong as I'm debugging my scripts. Oh, a nice side effect that came out of this is, let me continue the debugger here and finish that one now. Let me open up my file. So a side effect that came out of this was in figuring out how to add the capability to enter the debugger. I also fixed an issue that's been around in Wait Debugger for quite some time. If you guys know Wait Debugger, it allows you to tell the debugger to hang around and wait until you connect to it. So if you're in a run space or a hosted PowerShell inside of a process, it gives you an opportunity to tell the debugger, sit there and I'll connect to you and start debugging. But it's always had this annoying quirk about it, which is if I run my script, when I enter the debugger, it shows me I'm on $i++. But if you look at my script, I told it to wait for the debugger right here, but somehow it hits a breakpoint up here. And why does that happen? Well, that happens because in PowerShell core, when wait debugger is called, it tells the debugger to wait on the next command. So once I is finally equal to 9 in my little for loop, it tells the debugger to wait, and then the next command is i++, which would take it out of the for loop. And so that's where it looks like it stops. And that is just, I'm a bit of a perfectionist. As somebody who likes working in the debugger, that irked me. And so what I did was, part of this PR, I set it up so that it now stops on the actual wait debugger command. It's a small thing, but when you're dealing with loops and multiple levels of scope, it can be confusing to figure out when you hit the debugger this way where you hit the debugger from, even though it's from a command, just depending on the scope and functions and nesting, and it can be complicated. This way, if you invoke wait debugger, then it's going to stop on that command. And another side effect that came out of that change was I can actually just run wait debugger and enter the debugger and start poking around. And so if I want to learn the debugger, I can start tinkering with things right at that point. Just go in and figure out how things work. So those are 2 PRs that are almost approved right now to try to make the debugging experience easier. And then the only other thing, and this one's really hot off the press because I was just working on it, that I wanted to show you is
about 2 minutes.
Thanks. Is this one here. And so I'm working on a PR right now for terminating errors. Some of you people may be familiar with doing something like this inside of your functions, where inside of every process end block, begin block, you have a global try catch to make terminating errors actually terminate, and then doing write error. And it's a lot of scaffolding code that offers little value other than making things work the way that you want. And what I'm going to do here really quick is, oh, wait. Just kick off a build. I just have to do this because I'm working inside of the same environment, and this one was not in that other session that I had. Oh, wait a second. Which version am I in? Out of the start -ps build. So all this does is it makes terminating errors actually function as terminating, which for me this is something I've been working around for a long time with scaffolding, and it's really annoyed me again. And so I wanted to fix that. And so this isn't done, but this is something that I'm going to be submitting as a PR very soon. And if you guys have specific feedback on how you'd like to see that work, I'd love to hear about it either on Slack at PowerHour or Twitter, or reach out to me through GitHub. Any of those sources is fine. I don't think this build is going to finish in time just because I'm doing screen sharing at the same time, and so it's going a little slow. So that's fine. But suffice it to say, you're going to see, hopefully, in a PowerShell version update coming soon, not having to do scaffolding for try catch inside of every begin process end block, and having terminating errors actually properly terminate your PowerShell session.
Looking forward to it. That is time. We are up next with Joel.
Hey guys, this is Joel. Glad to be back. You may or may not remember me from the last time where I talked about my PowerShell koans module. This time around, I'm actually going to go back to basics here. Great follow-on from Kirk's with his PRs there. I want to actually take you guys through the very beginning of the process of actually getting a basic build of PowerShell core running on your system from the actual source code, and getting on to the basics of getting the PowerShell core repo cloned onto your system and getting the branching worked out. So first of all, I'm just going to quickly start off with just want to say that a lot of times that I've talked with people in the Slack or the Discord, a lot of people are not so much not wanting to contribute, but not knowing how to. So I thought I'd just put together a very basic thing here with you guys. So I'm just going to skip over the install Git bit because you guys can read this. I will have this up on the PowerHour GitHub after the session, so you guys can read through this. I've got links and everything, so you guys can come through. But basically, the first thing you want to do after installing Git is to go through and grab actually fork the PowerShell repo to your own account on GitHub. I'm going to breeze through this a little bit because I know time's a little short, but this is fully detailed in the Markdown document that I have. So once you've forked it, it'll take a few seconds, it'll copy it, and you can fork it. And then from there, actually what you do is you just come to this clone or download link, and you just copy this link right here. And I'm actually just going to do this as we go. So then you just go with your git command here, you just do git clone right here in here. And this will actually just download all the files, copy them for you. And it's basically in an almost ready state to start with. Kirk actually showed you the beginnings of actually building PowerShell from his pull request there. So what we'll do is something similar, but I just want to take you guys through from the very beginning, because in a lot of ways, it's not 100% intuitive if you've not done it before. And I know a lot of different folks have their own little workflows here and there. Some people prefer to build things through VS Code. Some people prefer to use full Visual Studio for this. But I think VS Code is plenty for a project like PowerShell. It's fairly lightweight and it works very well. As you can see, it takes a little bit of time to actually get the clone done, but that's okay. We have a few moments, and I'll just take you guys through everything here. What you can see here is actually my fork of PowerShell core, and I think this is still in the master branch, and I'm a little bit behind, so we'll do a catch up as well when I'm done cloning. But essentially, what you need to do is once you have it cloned, you go ahead and you want to keep it up to date with the actual PowerShell remote. So what we'll do is we'll just go ahead and change directory into our new repo here. And if we check git status, we can see, in fact, that we're on the master branch, nothing committed. We're all set to go, basically. From here, we actually got to go ahead and add the main PowerShell repository as a remote. So here we've got my fork. I'm going to go back to the main PowerShell repository here. And we're actually going to do a similar thing where I grab the clone link, but instead of cloning it this time, we're actually going to add it as a remote. So I'm going to add it. This is the remote name. I like to call upstream because it's upstream of the fork, so to speak. And we just do that, and it's quite easy. And we can check git remote, and we have origin and upstream. So now what you'll do is whenever you need to update your fork, update your master branch, you can do a git fetch, you can do a git pull. I'll take you through these briefly. As I mentioned, I have this relatively well detailed, and you can see like there's some new stuff going on that I haven't got in my fork here currently, which I will get in just a moment. But the first thing you want to do when working on someone else's project, an open source project, just working with someone else on GitHub, is you always want to make sure that you keep your master branch clean. It makes things so much easier. It really, really does. So we're going to come back to my fork here, and we're just going to go ahead and pull in from our upstream, which is the main PowerShell repository. from the master branch, and we just pull that directly into our master branch here. Give it a few moments, and it will just pull ahead. It will just pull everything in, and we're good to go. And then there's all our files here. We're all set to go. Everything's fancy and brand new, basically. And then what I like to do is just push it straight back to my. You won't always have to do this, but because I have done this a little on the fly, it's all good. So I'll just push this back to my main origin, which is my own fork. So now that we're all up to date, we're all set to go. So what you want to do when you're looking at working on someone else's project, you first thing you do before you do any code is you make a new branch. I can do this with commands. Like you can do this from the Visual Studio Code branching tools here with Git. With their Git interface, which is fantastic. We're just going to do a checkout B to create a new branch, and we're just going to. It doesn't really matter what it's called, and then we just do git push. And I think I have to do the same thing again. Yes, I do. This is usually a little more streamlined just because of how I set this up. It isn't 100%, but that's okay. There we go. So we go ahead and push this to our remote origin, which is our fork. And then if I actually go check my branches once it is done, perfect. If I check my branches, we have to refresh the page. You can see this branch is right here. It's test branch. Nothing's really changed yet. We can go ahead and change stuff. This code is miles deep. I've been in some of the depths of it. It's crazy. But let's just do something very, very simple just so I can demonstrate real quick. Here's the main PowerShell program. I don't really want to change anything just for the sake of this. I didn't really have anything on hand to just change out of the blue for this time around. That'll be next time. But I did want to show you guys. So when you have everything set to go, sorry, my bad. There we go. So once you have this all sorted, you will do your edits on this branch, right? And then once you have done your edits, you actually want to build PowerShell. That's pretty straightforward, as Kirk actually quickly showed us there. You will go ahead and just import the build module that is in the PowerShell repo itself, and you will execute the start.ps build. And for the first time, and for any time you have caught up to the master, it's a good idea to do a clean build. It will just regenerate anything that might have been missing or added as comments get added to the main there. This does take a few moments. So I'll just also take you through I've taken you through the branch. I'm just going to quickly take you through actually submitting a pull request. Once you have made some comments and pushed them to your fork on GitHub, you will often see, like it'll like I show here in this screenshot, it shows you you've pushed to a certain branch, and you can just compare and pull request right away. If I go ahead and press pull request on my fork here, it will automatically go to the PowerShell master branch. And if I actually make a change, it'll let me start a pull request. So if let's just say, this is going to be very simple, very straightforward. And here we go. I am actually going to really quickly jump into another console here just to make sure this gets done as it builds, because we are a little short for time, I feel, but that's just me. Okie dokie. So we're going to change cd into the PowerShell repository again, and we're just going to go once we are committed here. Perfect. All right, we just commit it from here. You can also commit from the command line, whatever you prefer to do. And then we just go git push right here, and that'll just trigger it to go ahead and push to the remote origin here. Here we go, our fork. And then if I refresh this, it'll actually show, oh, look, you changed something. You get a fairly complete breakdown of everything you've changed in case you forget something, or in case you change something you didn't mean to change. So what you want to do is give it a good title, and there are a bunch of comments in here and a little checklist to go through to make sure it is as it should be. Some of this process I have heard from the last community call is changing a little bit here and there, but I'm sure they'll keep everything sort of good to go there. And once you're done, you just press create pull request, and as Kirk himself displayed, the pull request is basically public as soon as you open it. If I go ahead and check mine real quick here, one that I already have open, for example. I have a few here, but this is a relatively recent one. And basically, you just do a summary of everything you do. If you have an issue you are actually fixing, you just, in the PR description, you put fix this issue number. And when it is merged, that issue will automatically be closed by GitHub. It just saves people some time. And yeah, so it'll give you a list of your comments, and then, you know, they will actually come in and review it for you. They're very great with that. It's awesome. It's really good to see a lot of that feedback, just to see how it goes. This one's actually incomplete. I have to do some more work on this one. But in the meantime, yeah, so I think we're all good to go. If I go back to my original window here. So we've actually done our build here. It's gone through all its background work here. And then if we go ahead and grab, it'll actually tell you where it outputs to, because it's hard to see sometimes and it's a few folders deep. So if you go ahead and just run that. And basically, this built version will include any changes you've made to the code. And if you happen to have made an error, it will tell you very promptly, usually, unless you've managed to do it in such a way that it isn't immediately obvious, as I have done a few times in the past. But it's great fun, actually. Personally, I would say it's great fun, just sort of changing things, seeing how it affects it, and seeing how you can possibly contribute. And as mentioned, I have a bunch of things going on in the PowerShell repo as well. So I've been excited to see what Kirk has. Okay, awesome. I'm about to ready to wrap up, honestly. So yeah, I just wanted to take you through this. As mentioned, that markdown document here, if I can get this, that markdown document here will be available on the PowerHour GitHub, which just which just lets you know basically the full steps to get through this from start to finish. So you have a working build on your own PC that you can tinker with. And I think that's probably the most valuable part of it, really, having your own little private section to just work in, mess around in. And if you break it, you just pull back in from the upstream PowerShell main repository, as I showed earlier. But thank you guys so much. I would hope to see many more of you guys contributing, because it is fantastic. It's good fun. And the more of us helping out, the better it'll get. So yeah, that's all for me for now, but have a good night, guys.
Thanks so much, Joel. Next up, Stephen. You are muted.
Yeah, just unmuted. There we go. All right, let's bring this up. All right, we're going to talk a little bit about BitLocker and PowerShell and how you can manage BitLocker using that tool set. A couple of things here. You're probably familiar, if you've used BitLocker in the past, with the CMD way of doing things. Manage BDE is the executable you use. And here is an example I just said. Here's my protectors, get C on this VM. And you can see that I've got a TPM ID, a numerical password, and then the actual recovery key for the disk itself. In Windows PowerShell, they've provided a module called BitLocker that includes a whole bunch of stuff that makes it a whole lot easier to do things to BitLocker, like suspend it, resume it, turn it on, turn it off, things like that. One of the cool commandlets they have available is the get BitLocker volume commandlet. And inside of that, you'll see that this device is fully encrypted, how big it is, and also that it has a couple of key protectors. So if you dive into this a little bit, actually, you know what? I want to show it this way. Key protector. It's not really very useful. But if you unroll it using the value at the end of your parentheses, you'll see that you get the same information back that Manage BDE gave you but it's in a more PowerShell friendly way to access things. Like, for example, if I wanted just the first object, I could get the first object, or the second object, I could get the second object. I could also just get the recovery password as a string, which is super handy. We'll get rid of this. You can also back up your keys to Active Directory. That requires a schema change. There's a couple of properties that you need to add to Active Directory to make those keys store in there. I'm sorry, I don't remember what those are off the top of my head. They're extremely convoluted, and they are not exposed by get80 computer. You have to use get80 object. I think it's something like get80 objects, where it's like computer dot name. And then you select, it's like ms-fve recovery. I think it's recovery key, actually, and that includes the password. So it's a really long, convoluted line. This is not very fun to get information from. But the first thing we want to do is actually get our keys to Active Directory. So PowerShell includes this backup BitLocker key protector commandlet, which just asks you which mount point you want to back up to Active Directory. In this case, it'll be the C drive. And then also it wants to know which key protector ID that you want to use. Well, given that it's PowerShell and we have the get BitLocker volume commandlet, if we just run this on its own, and we'll see, actually it's going to run the whole line. Let's put it down here. If we run that, you can see that we have our ID. If we save that to a variable and then just pass it in, we run this. I'm not connected to AD right now, or this would actually work. It'll throw an error right now, so it'll come back with an object that says this is my mount point. It's fully protected. It doesn't really tell you that it went to AD at all. It just gives you information about the disk. But if you see that output, you'll know that it went to Active Directory just fine. And then if you look in Active Directory later, you'll be able to see that on the Recovery Keys tab if you're in the GUI. If you need to quickly get a recovery key or any other information, I whipped up this quick function called get BitLocker key protector ID that also lets you grab that information remotely using PowerShell remoting if you supply a computer name variable to it. And then what key type do you want to use? Do you want the TPM, the recovery password, or both? And then we'll create a script block to execute. We'll grab those key protectors, and then based on what you want, the recovery password is always returned in position 0, and then TPM is returned in the second position, which is 1. And then if you want both, we'll just leave that off and grab everything. And by default, we'll also grab everything since the parameter is not required. So if you don't use it at all, you're going to get everything. Oops. And then we wrap everything up into a nice little object here to leave off some information that we don't really care about or necessarily need. So we'll grab the ID, we'll grab the type, we'll grab the recovery password, whether it is encrypted or not, and if BitLocker is turned on. And then we'll return that object to the screen for us to use. And then down here, if you've supplied a computer name or computer names, it will asynchronously execute that script block. If you don't provide a script block, it will just execute it right there locally on your workstation. So if I grab all of this and run it, locker key protector ID. You'll see that I've got a couple of IDs, TPM, recovery password, and then the recovery password as well. And then you can break into that with that same 0 and 1 notation if you need to pull individual items out. Or if you just need one of the items, you could say T, and we'll do is recovery password. We'll just get one single item back. Actually, it's still giving me 2 for some reason. Anyways. So that's a simple way that you can remotely grab that information off of the network with PS remoting. You can also do, I use this in my environment because the actual encryption process takes quite a bit of time to complete. So I'll use this function to give myself a toast notification on my machine whenever a machine is done encrypting. And we'll go ahead and step down through this. We give it a computer name, and I start it as a job. That way I can have my console back because I don't really want my console hogged up while I'm waiting for a toast notification to happen. I want to do other stuff. So we'll do a session to the computer because I'm going to go down here and create this other function that grabs just the percentage complete that the workstation is encrypted at. And then I will do a while loop that says, hey, while this is less than 100% encrypted, sleep for 5 minutes, and then check how far along it is in the encryption process. And then once it breaks out of there, I use the burnt toast module from Josh King to generate a toast notification on my workstation that it's done. And then at the end of it, I just get the session and remove the session as well. That way it's not sticking around. So if I grab all of this and run it, this will actually, this might run really quick, or it might sit around and wait a second. So
let's 30 seconds.
That might take a second to run. So yeah, there it is. So I get a toast notification when that is all complete. And that's basically all I wanted to show you guys. Just another way to leverage PowerShell to kind of manage your BitLocker stuff. It's really, really nice having those commandlets to unlock and suspend and resume because those support remoting. So if you need to do something on a remote workstation, you can, send those commands over there, turn BitLocker off for a minute, do what you need to do, reboot it, whatever. And then with the suspend commandlet, you can say just how many reboots do you want it to be suspended, set it to 1, do what you need, restart it, and it's encrypted again. Or if you need to, resume BitLocker again remotely over the network. It's a great tool to have in your back pocket. So that's all I got.
Thanks so much, Stephen.
All right, thanks, guys.
Okay, that brings us to the end of this this edition of PowerHour. Want to kind of let you guys know what's coming up. So we want to do another session soon. Want to do one as soon as we can, but for that we need submissions. The next one we're looking at doing will be a more European-friendly time. We're looking at doing about 6 p.m. UTC for the next one, probably early December, but we'll need submissions in order to fill that out. If you're not European, but you're able to fill in that time slot, then that's totally fine with us. We're happy to have you. We just figure this will give folks a good chance to participate. That's not at a time that historically has been really inconvenient for them. It's midnight or later, right? So we want to make sure that we can do a little bit better for folks a little bit more abroad. We hope you've had a lot of fun today, learned some stuff, and we look forward to seeing you again soon and to having you speak for us soon. Cheers, all.